In this lesson, we're going to focus on the WSDL, the service contract that's provided typically for every SOAP-based service. In general, there are two ways that you might get a WSDL. One is somebody might write it from scratch. That's unlikely anymore. There are utilities that generate the WSDL dynamically. So, for example, if you publish a SOAP-based service with either Endpoint or Tomcat or Jetty, those publishers will generate the WSDL automatically. That WSDL might be hand-tweaked to get some features that aren't in the machine-generated version, but mostly programmers allow the WSDL to be generated automatically. This is sometimes called the code-first approach to WSDL generation. The alternative would be called contract-first. So we're going to use the machine-generated WSDL, and the way you can get it, quite simply, is for any SOAP-based service, you can provide in Java the name of the WAR file, and then as a query string, $WSDL. We've seen this before, but let me show it again for review. And you can see the screen is now filled with XML, and this XML is part of the WSDL. Recall that the WSDL includes as a part an XML schema, so I'm going to move into my Emacs editor to look at the first of two working files. The first working file is rand-schema.xml, and it's basically the schema for the RAND services WSDL. It's very similar to schemas that we've looked at before. I've deleted some parts and left basically the parts that define the next N operation. This operation is the most interesting because the next N operation takes an argument and returns a list. There are two messages associated with this operation. You see the cursor in front of the first one. It's called next N. That's the request message that goes from the client to the RAND service. And the other SOAP message is next N response, and that of course comes back from the service to the client. So let's look at these in order. For the next N operation, there's a single argument. You can see it's called arg0, and the type is xs:\int. The xs: underscores that this is an XML type. It happens to have the same name as the Java primitive type, but this xs:\int is an XML schema data type. It's going to be mapped, of course, to the Java primitive int. The response message is a bit more interesting. So its name is called return. In the SOAP envelope, the element will be named return. Once again, the type is int, nillable equals true. This is a rather indirect way of saying that null in Java terms might be returned. In other words, what you're going to get back from the RAND service in a next N response is an array or the equivalent. For example, an array list, and either one of those in Java could, of course, be null. The minimum occurrences is 0. This would be the case if the response were null, and the maximum occurrences is unbounded because we don't know how long the list might be. Might be 2, might be 200. So the schema data types the messages. In this case, next N and next N response. The parts I've omitted up here are the similar definitions for the next one message, that's the request for a single randomly generated integer, and the next one response, which sends back a single integer. Now let's look at the full WSDL. So I've eliminated some parts but left others just to give you the feel. So as we saw earlier, the outermost element, the document element, is definitions. Then comes the types section. In Java, there's a link to the schema. We just looked at that. Then there's the message section. It's not so interesting. It's just an inventory of all of the messages. So what I've shown here are next N and next N response, and I've deleted next one and next one response. The port type is the section that we want to focus on a bit. In programmer terms, this is close to what we would call an interface. What it defines are the operations exposed in the service, and it defines those operations in terms of the messages listed above. Here's the next N operation. That's the request. It consists of two messages, an input and an output. Input is always from the perspective of the service. So this is a request message, the input message, and this is the response message, the message that goes back to the client. Because of the order, the pattern here is request response. Where the output message first, and the input message second, you would have a pattern called solicit response. Request response is the dominant pattern in SOAP-based web services. The binding section contains implementation detail. In a modern WSDL, the most important part of the binding is shown right here. It's the transport. So you can see here the transport attribute ends with SOAP/HTTP. So this is SOAP over HTTP. It might instead end with /SOAP, TCP/SOAP, SMTP, that would be email, and so on. By default, this is a SOAP 1.1 binding. In Java, you typically have only one binding, but you could have more than one binding. The service section puts it all together, and as noted earlier, in the service element are port sub-elements. And the basic idea is this: you'll have as many port elements as you have bindings. So in this example, there's a single binding section right up here, hence there's a single port. The port is conceptually the port type plus the binding. The most important element of the port you can see right here, SOAP address location. So this is the so-called service endpoint. It's the URL at which the service can be reached. XML is not something that we like to look at, let alone study and ponder over, but I think you can see that the WSDL is not particularly bad. Conceptually, it's well organized. You have data types. Those data types apply to messages. Those messages are put together in the port type section to create the operations. The operations, in turn, are bundled into a service, and that service has an endpoint, a URL, at which you can reach it. That's our relatively quick tour of the WSDL, including its embedded XML schema. In the next lesson, we'll put these again to good use by looking at Amazon.